Yeah, we want to check monotonicity of a given function. Monotonicity is nothing but in which interval the given function has increment, increasing or maybe decreasing. So we are talking about an interval. So if you have any function, by graph we can visualize some place maybe it will increase, some place it may be decrease. That place is nothing but a particular area. That area is nothing but maybe domain. So that is in between interval we will measure. That is nothing but monotonicity. For example, if you take this function f of x is equal to x plus 1 by x, we are going to check at which interval this particular function is increasing, at which interval the particular function is decreasing. Before that, I want to tell you how we will come to know about this increase and increasing. Just we have to make a graph. We know very clearly how to make a graph and the expansion of the graphs also. We discussed it earlier, right? But here, without making graph, still we can conclude whether the function is increasing or decreasing. If it is increasing, at what interval it is increasing, right? Before that, I want to give you one small rough work. See, if you have a function like this, say this is actually say x, and I am going to take just beside x, x plus h. This h is very close to 0. Very close to 0, because for better understanding, I just took maximum gap between x and x plus h, but you should consider that x plus h is very much close to x on right hand side, right? So that means very clearly we can understand x is greater than x plus h. X plus h is greater than x, right? Because some increment value there on x. So if you see that this particular x, if you consider this function as y is equal to f of x, this x is nothing but f of x, that y value. In the place of x plus h, you are going to have f of x plus h. So very clearly we can understand if x is increasing, f of x and f of x plus h also increasing. That means f of x plus h is definitely greater than f of x from this graph. But by the graph we can understand very clearly whatever values you are taking on the place of x-axis. So those all the values correspondingly you can have y values on y-axis. All these y-axis values are incremental values of x values. That means what? If x is increasing, y also increasing, because it is increasing graph. That means it is very clearly the graph itself is increasing graph. From this we can make it f of x plus h. I will take this f of x this side minus f of x, and that side nothing there means greater than 0. I will divide both sides with h. H is not 0, h is close to 0. If h is 0, division with 0 is illegal. Because h is close to 0, I can divide. So I am going to have f of x plus h minus f of x by h, and that side I have 0, and I am going to replace limit h tends to 0, because I already mentioned h is very close to 0. If you see this simply f dash x, so this f dash x is what? Greater than 0. So we can understand whether the function is increasing or decreasing, one can conclude by having a differentiation. So make differentiation and take all the x values which are greater than 0. Those values definitely nothing but an interval. In that interval the function is definitely increasing between x and x plus h. If you see this portion, it is increasing. Similarly, if you take something else, they are also increasing. I hope you got it. Now you have this function. If you differentiate it according to this concept, f dash x you are going to have, x differentiation is 1, and 1 by x you can write, it is x power minus 1. That means minus 1 x power minus 2, or 1 minus 1 by x square, or x square minus 1 by x square. So this is after differentiation we got it. Now what I can make, this f dash x must be greater than 0. Greater than 0. For any value of x it is a positive, so you can neglect. So x square minus 1 is greater than 0. X square minus 1 you can write x minus 1 into x plus 1 greater than 0. Remember, if you have any positive term, if you take this positive term to other side, multiplying with the positive term won't make this symbol any difference in this symbol. If it is a negative term, if you multiply, then the symbol may vary, greater into lesser, lesser into greater. Because for any value of x, x square is a positive because of even power. So you can make it x square into 0 is x 0, and greater than remains the same. So this inequality, how to solve, very clearly we discussed in inequality chapter. So x minus 1 and x plus 1. What are these critical points of x minus 1 and x plus 1? X minus 1 critical point is 1. X plus 1 critical point is minus 1. Critical point is nothing but if you replace x by that particular value, the whole bracket must be 0. So that is nothing but critical point or 0 polynomial. These values I am going to replace on a number line in an ascending order. This is plus, this is minus, this is plus, and this side is infinity, this side is minus infinity. So because of the greater, we can tick plus. If you have lesser than symbol, you have to tick only for negativity, right? Because of the greater, I have selected the portion of positive portions. So 1 to infinity is one positive portion, and minus infinity to minus 1 is another positive portion. Portion in the sense this plus lies between minus infinity to minus 1. Because we have two infinity, always we have to close with open bracket, and minus 1 and 1 are given by the numerator. So therefore numerator critical points, you can have an option of closing with either closed or open. You have two options. But whereas if these critical points, if you got by denominator, always with open brackets but not closed because of the denominator, right? So we, in this particular problem, we got critical points from the numerator, so we have double options. You can go with a closed bracket or you can go with open bracket. But which bracket actually really suitable for us? Because there is no greater than or equal to, we have only greater than. Because of only greater than, we have to open. If it is greater than or equal to, so that means those values we have to include, so we should use this bracket. I hope you got it. X belongs to minus infinity to minus 1 as well as in between 1 to infinity. The given function x plus 1 by x have incremental value. So I hope you got how to find monotonicity.